Hello students, welcome to a series of mathematics program for grade 10. The topic for today is variation, the second part on this chapter. So the first part of the chapter was direct variation, and the second part is inverse variation. The learning objectives for today's lesson are to express inverse variation in algebraic terms and to use this form of expression to find unknown quantities. Let us have a recap of what was done in the first video. You will remember that in the first lesson, we had learned about direct variation. So if y varies directly as x, then we can simply write it as y equal to kx, where k is a constant. Now we are going to look at inverse variation. So let us consider this table. You have in the first row the speed denoted by x in meters per second. And in the second row, we have the time taken denoted by y in seconds. So look at this table carefully and try to observe what is happening between the values of x and y. So here we can see that as x increases, y decreases. That is, as the speed increases, the time taken decreases. In fact, we can also see that as x is doubled, for example, from 10 to 20, y is halved. You can see we had 50 corresponding to a speed of 10 meters per second. And when I double the speed, the time taken is halved. We can further notice that if we multiply x by y, 10 times 50 is 500. 20 times 25 is 500. 40 times 12.5 is equal to 500. Similarly, for the other two columns, when we multiply x by y, we get 500. In other words, xy, which can also be written as y divided by 1 over x, will be equal to 500. That is, the corresponding value of y over the value of 1 over x is equal to a constant. We can write it as y divided by 1 over x equal to k, or simply y equal to k over x. So we can say that if y varies inversely as x, written as y varies inversely as x, this would imply y equal to k over x, where k is a constant. So you will remember that for direct variation, we had y varies as x, written as y equal to kx. Whereas for inverse variation, if y varies inversely as x, we write it as y varies inversely as x, that is 1 over x, and we write it as y equal to k over x. Let us have a look at the first example. If y varies inversely as x and y equal to 10 when x equal to 6, find part A, an equation connecting y and x. Part B, the value of y when x equal to 3. And part C, the value of x when y equal to 25. So we have been given that y varies inversely as x. So we write it as y equal to k over x, where k is the constant. Now, we were also given when x equal to 6, y equal to 10. So we replace these values in the equation y equal to k over x. We get 10 equal to k over 6. So k will be equal to 10 times 6, which is 60. Now, the equation connecting y and x is y equal to 60 over x. Part B, I need to find the value of y when x equal to 3. So the equation was y equal to 60 over x. I replace x by 3 and I obtain y equal to 20. Now for part C, I need to find the value of x when y equal to 25. So I use the equation y equal to 60 over x and I replace y by 25. I get 25 equal to 60 over x. That is 25x equal to 60. And simplifying, I get x equal to 60 over 25, which will give me 2 to 5th. Now the second example. Given v varies inversely as s squared, copy and complete the table below. We have a look at the solution. So we were given v varies inversely as s squared. This can be written as v equal to k over s squared, where k is a constant. Now, we were given this table, and here in this column, we were given both the value of s and the value of v, which is what we will be using. So when s equal to 1.5, v equal to 8. Replacing these two values, we have 8 equal to k over 1.5 to the square. So k will be equal to 18. That is 8 times 1.5 to the square. Now, even if we have not been asked to find the equation connecting v and s, we can still find it because we needed to find the other answers. So the equation will be v equal to 18 over s squared. Now, when s equal to 1, I replace in this equation v equal to 18 over s squared, s is 1, and I get v equal to 18. Next, when v equal to 2 now, I need to find s. So 2 equal to 18 over s squared. That is 2s squared equal to 18. S squared will be 9. Now, S squared equal to 9 will give me S equal to plus or minus 3. Remember, 3 to the square is 9, or negative 3 to the square is also 9. So I get S as plus or minus 3. Let us now consider example 3. This one is slightly different. I'm sure you will remember that in lower grades, you had covered the chapter proportion. We had direct proportion and inverse proportion. So inverse variation is same as inverse proportion. If 6 men can do a certain job in 8 hours, how long will 24 men take to do the same job, assuming they all work at the same rate? So if 6 men take 8 hours to do a job, will 24 men take more time or less time? Try to think. 6 men take 8 hours. 24 men will take less than 8 hours to do the same job. So suppose X men take Y hours to finish the job. More men will mean less time. So more men will take less time to do the given job. Therefore, we say that Y varies inversely as X, because as X increases, Y will decrease. So we have inverse variation. This can be written as Y equal to K over X. Now, substituting Y equal to 8 when X equal to 6, we get K equal to 48. So Y equal to 48 over X will be the equation connecting X and Y. We now need to find when X equal to 24. So Y will be 48 over 24, which is 2. Therefore, we will need 2 hours to complete the job if we have 24 men. Remember, when we had 6 men, the job took 8 hours. Now, when we have 24 men, the job will take less time, that is, it will take 2 hours. So now you have some questions for you to practice. The first question was simple. Y varies inversely as X. The second one, you will have Y varies inversely as X squared. The third one, you have Y varies inversely as square root of X. Questions 4 and 5, you will have to copy and complete the table. So for example, for question 5, we have Y varies inversely as the cube root of X. Question 6, here you have L is inversely proportional to the square root of A. Question 7, given that V is inversely proportional to H plus 3 and V equal to 4 when H equal to 2, you need to find the value of H when V equal to 12. Question 9, the time taken to cover a given distance varies inversely as the speed of the journey. If it takes 5 hours to complete a journey, when the speed is 60 kilometers per hour, how long will the same journey take if the speed is now increased to 75 kilometers per hour? You also have some interesting links. I would advise you to go and visit these links so as to get additional practice on both direct and inverse variation. So students, we have reached the end of today's lesson. Let us see what we have learned. We have learned how to express inverse variation in algebraic terms and how to use this form of expression to find unknown quantities. So you will remember that for direct variation, y, for example, y varies directly as x, we write it as y equal to kx. Whereas if we have y varies inversely as x, then we write it as y equal to k over x. So students, we have reached the end of this chapter. I hope you have understood both direct variation and inverse variation. Remember, you need to practice the exercises given in this video as well as the questions found in your book. So until we meet again, it's goodbye from me. Thank you for your attention.